Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a trigonometric equation with complex numbers. If you're new to complex numbers, go ahead and check out my lecture videos. If you like algebra, number theory, trigonometry, go ahead and check out my other channel, which is my first channel. I have 3 channels, by the way. One is for shorts, which is called the Cyber Math, cyber with an S, not with an C. And by the way, I'm not from Siberia. Cyber means something else. Anyways, so we have this equation. How do we solve for it, right? Like I said earlier, if you're new to complex numbers, go ahead and check out my lecture videos. I go over the basics. If you have any questions, please ask, because that's the best way to learn. Don't hesitate, okay? I'm pretty sure somebody will answer. All right, and let's go ahead and take a look. So we have this equation. This equation could also have been written differently. Like we could have written this as cosecant theta plus cotangent theta equals I. Would that make a difference? Not really, because if you were given this, you'd probably convert it to sine and cosine, because working with sine and cosine is so much fun and a lot easier than dealing with something like cosecant. What is cosecant? It is the reciprocal of sine, but we barely use it, okay? It's even weird, like, because some people will spell it like this, and some people will use 3 letters, especially in the US, they use it like that because it needs to be standard and you can only use 3 letters. Tan, cotangent. Some people write cotangent like this. Doesn't matter, they all mean the same thing, right? So let's go ahead and see how we can solve a problem like this. So we're gonna forget about the sine, secant, cosecant, whatever conversion. Let's just stick to the original problem. To be able to solve this problem, there's a couple different ways to go about it. I think I'll be presenting at least 2 methods. Let's start with the first one. My first method is basically going to be using the half angle formulas. And the reason behind that is this expression can actually be simplified really nicely. Do you know how that works? So let me tell you. Cosine of 2x has 3 formulas, but I'm only going to write the one that I'm going to use, which is 2 cosine squared x minus 1. And sine of 2x can be written as 2 sine x cosine x. Thank God we only have one expression for sine of 2x. But cosine, like I said earlier, there's 2 more. So if you, how am I going to use these though? We don't have 2x. Yes, you do. If you set theta equal to 2x, then you're going to have the following. 1 plus cosine 2x divided by sine 2x. Now you have the 2x. You see what I'm talking about? It's a lot easier if you do the substitution. Don't worry about the half angles. Now you're dealing with double angles. It's the same thing, sort of. So now we're going to replace cosine 2x with 2 cosine squared x minus 1. And the sine 2x would be 2 sine x cosine x. Great. Now see how this is going to simplify. First of all, negative 1 and positive 1, and then the 2's, and then one of the cosines with this one. This gave us cotangent x. Beautiful. But what is cotangent x? I don't really like that, right? Isn't that 1 over tangent? Yeah, fine. I mean, but what is x? If 2x is theta, that means x is half of theta. Great, right? That's what I meant by half angle and double angle stuff. So we have cotangent x, or cotangent theta over 2, which is the result of this. Of course, under certain conditions, you don't want sine theta to be 0. Be careful. Just try to remember that. And this is equal to I. Okay? What did I say? I said sine theta should not be 0. Cool. Just keep that in mind. So how do we solve an equation like this? Well, maybe we can invert it, because tangent is a little easier to deal with. So we can write this as tangent of theta over 2 is 1 over I. But 1 over I is negative I, because we're going to multiply by negative I over negative I. Negative I squared is 1. This becomes negative I. So we have now tangent theta over 2. Do I have to write that in parentheses? I don't think so, but some people are very picky about it. Okay, too bad. So tangent theta over 2 is negative I. That's interesting. We have a half angle, so let's draw a triangle with theta over 2, because I can double it or cut it in half or double it. Well, I'm supposed to double it, so maybe make it a little longer, like this. Okay, make that angle small. This is theta over 2, and we have a negative I, so tangent is negative I over 1. From the Pythagorean theorem, a squared plus b squared equals c squared. I squared plus 1, let's call this c, equals c squared, but I squared is negative 1. This becomes 0, so c is 0. Okay, great. Awesome. You weren't expecting that, right? A right triangle with 0 hypotenuse. Of course, that doesn't exist. So, Houston, we have a problem. How do we solve this problem? That's called special forces, right? Okay, so we're gonna use some hocus pocus techniques. First of all, notice that tangent cannot be I. And for the same reason, it cannot be negative I either, because I and negative I are close. I mean, they're conjugates and they are reciprocals and so on and so forth. They're really good relatives, right? So what does this mean though? That means there should be no solutions? Well, here's the thing. If tangent theta over 2 is negative I, then as you can see from here, sine theta over 2 and cosine theta over 2 is undefined, because you can't divide by 0, right? I mean, these are ridiculous expressions. Okay, it's not indeterminate, undefined, infinity, something like that. So when you want to find the sine of theta, which is sine of 2x, you must multiply the, so in other words, you got to do this, right? This is undefined, undefined, so this is undefined. And remember what I said about that. It can't be 0, right? Well, it can't be undefined either, obviously. You want sine theta. It can be complex, that's fine. Sine theta can be I, negative I, 1 plus I, anything like that. But it can't be 0 in this case, and it can't be undefined either, because that would be problematic. And what happens if you divide something by infinity? That would be 0, so I would not equal 0, right? Great, okay, anyways, this is the first method. The conclusion is no solutions. All right, let's go ahead and talk about the second method, because I think second method is really, really cool. And you're gonna decide which method is the coolest. So we have 1 plus cosine theta over sine theta equals, I don't know what you thought when you first saw this problem. Share with us what you thought. But here's my thought when I first came up with this problem. By the way, this is not entirely new. I've seen similar problems before, but I just thought about this version. I thought about cross multiplying, because why not? 1 plus cosine theta equals I sine theta. And this is kind of cool because that reminds me Euler's theorem or Euler's formula. What is it? E to the I theta equals cosine theta plus I sine theta. So there's something magical, maybe mathematical, about I sine theta, and I just have that. Beautiful. So why don't we put those together like the thetas, right? Let's put the cosine on the right-hand side. In other words, write this as cosine theta. Actually, you know what? I want to keep the cosine positive. So why don't we bring in the I sine theta? Why don't we bring this over here and then put the one on the right-hand side as a negative one? So in other words, this is what we get. Cosine theta, come on, notability. Calm down. Cosine theta minus I sine theta equals negative 1. Beautiful. Now, Euler said this is e to the I theta, but he didn't tell us what this is. Did he? Maybe he did. I don't know. Maybe I missed it. But we can actually convert it. How? Using the special forces again. A little bit of mathemagic, a little hocus pocus here and there. And that is the properties of sine and cosine. Sine is odd, cosine is even, which means sine of negative theta is negative of sine theta, but cosine of negative theta is cosine of theta. Cosine absorbs, sine spits out. In other words, cosine will just absorb the negative. So we can now write this as cosine of negative theta plus I sine negative theta equals negative 1. And then from here, we should be getting something like e to the power negative I theta equals negative 1. And what is negative 1? It is e to the power I pi, isn't it? If you think about the Argand plane, you know, the unit circle, whatever, this is pi radians, and this is 1, so on and so forth. So what does that mean? It means negative I theta is I pi. I cancels out, theta is negative pi, or you can write it as pi. They are the same. But if you plug in pi, sine theta would be 0. And remember what I said, sine theta cannot be 0. So again, no solutions. Is there a third way to solve this problem? I don't know. Maybe there is. Let us know if you know of a third method. Because this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.